name is Captain Darshana and today we will be studying about the chapter Earth. So what we will look at today is the shape of the Earth, what is compression, then we will look at directions, what is gratitude, also a little bit about latitude and longitude, what is a great circle, what is a small circle, and also what is a rhumb line. So let's get started. So first we will look at the shape of the Earth. The shape of the Earth is known as oblate spheroid. Now what is an oblate spheroid? Earth is not a complete sphere or a complete circle. It is a little bit bulging at the equator and flattened at the poles. That is the exact shape of the Earth, like you can see in the picture over here. That means if I draw a line like this about the equator, and if I also draw a line like this connecting the poles, the line that I have drawn at the equator is longer than the lines that we have drawn here at the poles. So let's call this line the equatorial diameter or ED, and let's call this line as the polar diameter or PD. So in this case your equatorial diameter is going to be greater than the polar diameter, and that's what it means. There are two more names to this. You can also call it an ellipsoid and you can also call it the geoid. So this is basically what the shape of the Earth is. Now as I said that it is flattened at the poles and bulging out at the equator. So I can also say that the Earth is compressed from the poles because it is a little bit compressed, and this is known as the compression of the Earth. So what really is the compression is we will compare the equatorial diameter to the polar diameter, and we will give it some values as to how much is the equatorial diameter greater than the polar diameter. So in this case the equatorial diameter is greater than the polar diameter by 27 statute miles or 23 nautical miles or 43 kilometers. We can also express it in a percentage, which is 0.3%, and we can also express it in a ratio, which is 1/300, and we call this the compression ratio. There is a formula as well to calculate this compression ratio. So the formula for compression ratio will be equatorial diameter minus the polar diameter divided by the equatorial diameter. And you can get questions based on this formula where they will give you one or two values and you have to find the other. And this is what we call the compression. Let's move on. After compression, let's look at mapping of the Earth. So now this is your Earth, which is obviously a sphere, but we will have to map or project this entire Earth onto a piece of paper. Now since this Earth is not a complete sphere and it is a little bit compressed, there are different ways and different methods by which you can map the Earth. But in aviation we use only one kind of mapping. We call the model World Geodetic System 1984. And this is the only one that can be used all over the world. It is given to us by the ICAO. ICAO is the International Civil Aviation Organization who makes the rules for aviation all over the world. And that's all about the World Geodetic System. Let's look at some directions now. We know that there are four basic directions. This is your north, your south, this is your east, and this is your west. Now we are going to number all these directions. Starting with north, if I draw a line like this is starting with 0, but we will always express it in a 3-digit and not just in 1 digit. So we say this as 0, 0, 0. Now if I want to express east, I will draw a line like this. Now as you can see, it is making a 90-degree angle with north. So my east direction is a 90-degree direction. So every direction is nothing but an angle which is measured from the north or from 0, 0, 0. And as I said, we will only express it in 3 digits. So this becomes 0, 9, 0. Similarly, if we come to south, now this is my entire angle from north, which I know is a 180-degree angle. So this would be 180. Coming to west, Now this entire angle is a 270 degree angle. So west direction can be expressed as 270. Now I can also come back like this to north. This becomes an entire circle which is a 360 degree angle. So north can be expressed as either 0, 0, 0, or I can also express it as 360. You can use either or for north. Okay, now these are the 4 basic directions. Let's look at some more directions over here. So we've already said north, south, west, east. Let's look at another direction which is right here. So this is north and this is east. So this becomes your northeast. Now this angle that it is making with north is a 45 degree angle, which is half of 90. So this becomes 045. Similarly, if I draw a line here, this becomes my southeast. Again, this is the angle. Angle is about 135 degrees. Similarly, if I draw a line here, this angle now, this is my west. So this is your southwest. So this angle is about 225 degree angle. Similarly, if I draw a line here, this becomes my northwest, and this angle is my 315 degrees. And this is how you denote all directions. So every direction can be given a number which has to be a 3-digit number, and it has to make an angle with north. This is what it looks like. So starting with 360, I can say this is my 090, 080, 070, 060, 050, 040, so on and so forth. After 90 also we'll write 100, 110, 120, all the way to 180. Then 190, 200, 210, 220, all the way to 270. And that continues, of course, from 280, 290 until the 360. And that's it about directions. So I hope the direction part is clear and how we have numbered all the directions. Okay, let's move on to the next part. Next part, we are going to look at the earth and all the lines that are drawn on this earth. So you see this earth has many lines that are drawn on it. Let's look at all the line one by one. First, we will look at the most important and the basic one, which is this line. Now, as you can see, it cuts the earth into 2 equal parts, which is the upper part, northern hemisphere, and the lower part is known as the southern hemisphere. And this entire line, we call it the equator. Right? So it divides the earth into northern and southern hemisphere. So like how you have a horizontal line like this, we also need to have a vertical line that divides the earth into 2 equal halves. So let's say that this is that line that divides the earth into 2 equal halves. So this side becomes my western hemisphere and this side becomes my eastern hemisphere. Now of course this is not just a line, this is an entire circle that comes on one side, and on the other side of the earth it comes back and touches it. So it's actually an entire circle that goes around the earth. Now this particular line is known as my prime meridian. It can also be called Greenwich meridian. It is called Greenwich meridian because it passes through a town called Greenwich, which is in London, and that's where it gets its name from. So this way, these are the 2 main lines that divides the earth into 2 equal halves, vertically and horizontally. But that's not it. As you can see, there are some more lines. So let's look at what those are. First, let's look at all of these horizontal lines. So here we'll look at here. So if you look at these horizontal lines, this is one, there can be one more, as well as over here. So except the equator, all the other lines that are horizontal, we call them parallel of latitude. They can also be called as latitude. And we will look at detail of it in a bit. Similarly, we also have vertical lines. Of course, like I said, the one in the center is the prime meridian, But that's not it, because there are many other lines as well that are these vertical lines. So all the other lines that is not the prime meridian, we call it the meridians only. But as you can see, it comes from one side of the earth and from the other side it will come back and join that circle. So one half of it is known as a meridian and the other half of it, we call it the anti-meridian. So this way we have meridians and anti-meridians. We also call these lines as longitudes. We will look at longitudes in detail as well. But these are the main lines that are there on the earth. So let's revise it a little bit. We have equator that divides the earth into northern and southern hemisphere. We have the prime meridian that divides the earth into eastern and western hemisphere. And we also have the parallel of latitudes and the meridian and the anti-meridian. Now a network of all these latitude and longitude is given a name. We call it the graticule. So what is a graticule? Graticule is nothing but a network of all the latitudes and longitudes. So basically all the lines that are there on the earth. I hope this is clear. Let's look at latitude and longitude a little bit in detail. Because all of these lines, I know that they are latitudes, but they are given a specific number. Now why do we give them a number and what is that based on is what we will look at. So this picture describes it the best. Let's assume that we need to understand what is the name given to this latitude, the one that I have drawn over here. Latitudes are numbered always as an angle and this angle is measured from the equator. So as you can see, this is my equator over here. Now I have drawn an angle till that point from the equator and I will measure this angle. Now in this example, this angle is a 45-degree angle. So then this latitude line is also known as 45. But because it is in the north, I will also write an N ahead of it. So this is north 45. But it can also be in, it is especially in degrees, but it can also be in minutes. So what are minutes is, 1 degree has 60 minutes. So let's say I want to denote this latitude, which is about 45.5 degrees. So how do I denote the half? 6 minutes, half of 6 minutes is 30 minutes. So this becomes my 45 degrees and 30 minutes north latitude. So it depends on what the angle is and depending on that, names are given to these latitudes. Latitudes are always given as a 2-digit only. Because if you notice, what can be the maximum latitude here? This can be the maximum latitude, which is a 90-degree angle. So my maximum latitude is north, which is 90 degrees north. Similarly, this can also be in the south. So let's look at another example. Let's say this latitude I want to denote or number it. So I will from the equator draw a line over here. This angle looks like about a 30-degree angle. So therefore this latitude I can call as north 30 degrees. Again it's 2-digit. If there were any minutes, I would have written whatever the minutes are after that. And that is what latitude is. Moving on to what is a longitude. Now longitude are also numbered. Now how are longitude numbered? Let's look at that. Longitudes are also an angle. So let's say in this example, a blue line, a yellow line that you can see is our prime meridian. And I want to denote the longitude of this white line, this one. So what I will do is I will mark or I will see what angle does this particular line make with the prime meridian at the equator. So this is my equator. So how you see how this angle is measured at the equator. Okay, so this angle is a 40-degree angle. Now this is of course to the west side. So I will name this as W and it's a 40-degree angle. So I can say 40 degrees. But whenever we write longitude, it is always going to be 3 digit and not 2. So I will have to write a 0 in front of it so that it becomes a 3 digit. Here also there can be degrees and minutes. So this becomes west 40 degrees. So west 040 degrees is nothing but a west longitude, which makes a 40 degree angle from the prime meridian. Similarly, if let's say I want to take this longitude. Now this angle from the prime meridian to the equator, if I see, this is a bigger angle. Let's say it is about a 60 degree angle. So this longitude becomes east because it's on the east side, 060 degrees. And that's it. I hope latitude and longitude is clear. Now if you look at the maximum angle can be all the way till behind. This entire angle can be one angle. So my maximum angle in this case can be 180 degrees east or west. So for longitude, the maximum angle is 180 degrees east or west. And that is about latitude and longitude. Now there are some calculations that we will look at as far as latitude and longitudes are concerned. So let's see what those calculations are and solve it together. So now we will do some calculation with respect to latitude and longitude. So I hope you've understood what is latitude. What we will have to do is calculate a change in latitude. So how do we calculate a change in latitude? First and foremost, a change in latitude, you can say it in a short form. We call it chalat, we write it like this. We can also call it a difference in latitude, and you can also call it delat. You basically need to find the difference between two latitudes or the change between two latitudes. So let's take an example that you want to calculate the difference between 40 degrees 20 minutes north and 18 degrees 40 minutes north. So first we will make a diagram and draw this out. So how do we draw a latitude diagram? We will first draw a circle and we will draw the equator right here. This is my north and this becomes your south. Now let's make an angle from the equator because we know that is what latitude means. So the 40 degrees and 20 minutes north will be somewhere about here. So this latitude is 40 degrees 20 minutes north. The second latitude is a smaller angle, so it will be somewhere over here. Okay, so equator is your 0 degree basically. Now this latitude, as you can see, is 18 degrees and 40 minutes north. Now you need to find the difference between these two latitude, which is this angle. So in this case I will have to subtract the two to find this angle. So in your calculator you will do this. We need a scientific calculator for it. On the calculator you will type in 40 and then you will type in the degree sign and then you will write 20 and again type in the degree sign. So this becomes 40 degrees and 20 minutes. Now I subtract it. So on a calculator you put minus and again you will write 18 degrees and 40 degrees and then you press the equal to sign and you will get your answer. And this is how you calculate a difference or a change in latitude. In simple terms, you can also say that if at all two latitudes are in the same hemisphere, that is if both are north, you can just subtract it. And if you see from 40 north, I want to come down to 18. So you see I am following a path towards the south. So the direction that you are following will be a south direction. But your difference in latitude will still be north in this case. Okay. So I hope that this is clear. This is how you calculate delat if they are in the same latitude. Let's look at delat if at all they are in different latitudes. So let's take another example of difference in latitude between 40 degrees north and 20 degrees south. So again we will draw a circle. This is my equator and from here a 40 degree north angle will be somewhat here and a 20 degrees south angle will be somewhat here. In this case the angle that we need to find is this entire angle. Now this angle is nothing but 40 plus 120 because we are adding in this case. So, this becomes 60 degrees is my D lat in this case. And as you can see, I am going in this direction like this. Now, since I am going in this direction, again my direction is south. So, I will say south 60 degrees because I am going in a southerly direction. That is how you calculate the difference in latitude. Let us do the same for longitude. So, what we do is D long. This way we can find what is the difference in longitude. So, again let us say I want to calculate the difference between 40 degrees east and 120 degrees east. Now, the diagram for D long or the difference in longitude will be a little bit different. So, what we do is we draw a circle. Let this be like a top view from the earth. So, you are looking at the earth from the top and this is like your pole. So, I will draw a straight line here like this. This is my 0 degrees and this is my maximum 180. If I go this side, I am going in a westerly direction. If I go this side, I am going in an easterly direction. So, first is a 40 degrees east, which is in an easterly direction, which is this side. An angle will be measured from here. So, from here, this angle, and this is my 0, this angle looks about 40 degree angle. And this position is my 40 degrees east. Second is 120 degree east. So, I can see here this would be my 90 degree. So, 120 will be somewhat here. So, this angle now is my 120 degrees east. Now, I need to find the difference between the two. In this case, that difference is this angle. So, it is nothing but the entire 120 minus 40. So, all we do is 120 minus 40, which is 70 degrees. Now, this angle is your D long, and as you can see from 40 to 120 I am going in this direction like this, and since I am going in this direction I will match it with this arrow because this arrow is also similar. So, I am going in an easterly direction and I will call this east 70 degrees. And this is how you calculate the difference in longitude. Let us look at the difference in longitude for different hemispheres. So, let us say that I want to calculate D long between 20 degrees east and 20 degrees west. So, again we draw a circle like this. This is 0, this is 180. We draw an arrow going like this, which is west. We draw another arrow which is east. Now, 20 degrees east we will measure from here. So, this is 20 degrees east and to the west is somewhat here 20 degrees west, and this entire angle now is my D long. In this case I will add them. So, 20 plus 20 gives me 40 degrees. Let us see direction. You are going from east to west. So, like this, which arrow is this matching? This is matching this arrow. So, I am going in a westerly direction. So, this is nothing but 40 degrees west, and this is how you calculate D long. Please make sure that you draw the diagram every time you calculate this so that you know which direction you are going in and there are no mistakes made over here. That is it of how we calculate D long and D lat. Let us look at some basic definitions now which we need to look at. The basic definitions that we will be looking at is your great circle, small circle and a rhumb line. So, let us see what those are. So, let me draw an earth first. Here, this is your earth. Now, great circle. What is a great circle? The largest circle that you can draw on the earth is known as a great circle. In this case, if I notice, the equator could be the largest circle. And another thing is the center of the earth and the great circle's center, both of them will be the same. So, the great circle as well as the earth will have the exact same center. So, in this case they do have the same center. So, equator is a great circle. Another thing is if I draw a meridian and anti-meridian, it will also have the same center. And any meridian and anti-meridian that you draw will all have the same center. So, all the meridians and anti-meridians are also great circle. Now, whenever you are flying a great circle track, it is always going to be the shortest distance between any 2 points. That being said, it does not follow the same direction. What I mean by that is when I am flying a great circle track, my direction changes constantly. It's not a same direction all along. So let's say if I start from here, my direction will be 0, 3, 0 that I am flying, and by the time I get here it can become 0, 2, 0. So I have to constantly change my heading in order to maintain a great circle track, but it will always be the shortest distance between any 2 points, and that is your great circle. Let's look at small circle. Now small circle is exactly opposite of great circle. Any circle that is not a great circle is a small circle. So let's draw some more lines over here and see what are your small circles. So these lines, which are the other parallel of latitudes, right, they do not have the same center as the earth. So these parallel of latitudes now become your small circle. Moving on to what is a rhumb line. Now what is a rhumb line? Rhumb line is actually a curved line or a regularly curved line that I can draw on the earth, but it is not the shortest distance between any 2 points, although whenever you are flying a rhumb line track, you will maintain a constant heading or a constant direction. For example, if I am following this equator like this, I know the only heading that I need to maintain is 090 to get to this place to this place. Now this can be a rhumb line and this can also be a great circle because it's the equator. But let's look at another example. Let's look at a parallel of latitude if I'm flying. Let's say this is 60 degrees north. And if I'm flying this parallel of latitude exactly, what's going to happen is, because all the meridians that are there over here, okay, they cut all the parallel of latitude at the same angle. Therefore, when an aircraft is flying this, it is also maintaining a constant track, because track is nothing but the angle that you make with the meridian. So in this case, the aircraft is following the same track constantly, which is known as a rhumb line track. But it is not the shortest distance, because as you can see, it is a curved line. For a shortest distance, it has to be a straight line. This line will become my shortest distance, but here all the angles are different. See, this is a smaller angle, this is a 90-degree angle, this is a bigger angle, this is even a bigger angle. So I have to constantly change my track in order to follow that line. Whereas in this case, it is not the shortest distance, but I don't have to worry about the track. So all these parallel of latitudes are nothing but rhumb line tracks. With that, we complete the Earth chapter. So let's just go over what we did today. First and foremost, we looked at the Earth. So let's just see what all we studied in Earth. First, we saw the shape of the Earth, which is an oblate spheroid, ellipsoid and geoid. Also, we looked at what is compression. In compression, we saw the different values of compression and also what is compression ratio. And then we did our World Geodetic System 1984, which is the mapping of the Earth, which is given by ICAO. After that, we looked at all the lines that are there on the Earth. We also did directions. Now, let's revise all the lines that are there. We have equator, we have meridian, we have anti-meridian, we have Greenwich meridian, we have latitude, longitude, and we also said all the directions are given some numbers, and we looked at what those numbers are. After this, I showed you what is latitude and what is longitude and how do you calculate latitude and longitude. After that, we also did 3 main definitions, which is your great circle, largest circle that you can draw. Small circle is anything that is not a great circle, and a rhumb line is a line that cuts all the meridians at the same angle to maintain a constant track. And that completes the introduction to Earth. Thank you.